Okay, I'll get started now. Please, if you have any trouble hearing me, just let me know in the chat. So my name's Talor Holloway from Advent One, and I'm going to talk a little bit about how we use Runecast as a managed service provider, and also how we use open source automation tools in our customers. So the agenda that we're going to go through is how to use Runecast, some open source automation tools that are out there, and specifically we're going to talk about Ansible and Ansible Tower, talk about some use cases and some benefits that we've seen in our managed service practice and in our clients. So just a bit about us, our areas of expertise listed here. This is not an exhaustive list, but some of the key areas that we work in is the provision of infrastructure and platform services across private, public, and hybrid and multiple cloud solutions. We help our clients automate and adopt DevOps practices and help containerize and modernize their applications. We've got a cybersecurity practice. We've got a long history in backup, disaster recovery, and business continuity. And obviously, as I mentioned earlier, we've got a full suite of managed service offerings. So how do we use Runecast? So if you look at the box at the top, that's a kind of a bit of a mud map of some of the tools that we use. So looking at the right-hand side, we've got obviously some databases for metrics and reporting. We've got some tools providing dashboards and reports, security services. We've got Ansible Tower in there, which we'll talk a little bit about, and some monitoring tools. We also have in our management environment the Runecast Enterprise Console that's set up, which provides us visibility across best practices, which predominantly for us is in VMware. However, it's got a lot of information around AWS and now Kubernetes. Upgrade simulations, if we need to do a VMware upgrade, we're able to check that all the compatibility is okay and that our upgrade is going to work. We align to the SIS benchmark from a security standpoint internally and for our customers, unless there's another security standard that they need to adhere to if they're regulated in financial services or HIPAA in healthcare, etc. And also, it's now a new feature in Runecast is the ISO 27001 ISMS. So we then have Runecast analyzers out at each of our customers at remote sites, which can feed up and send information to our Runecast Analyzer. So hopefully that gives a quick snapshot of how we use Runecast and a couple of things that we use it for. So there are a number of open source automation tools. This is certainly not an exhaustive list. So Ansible, Terraform, Puppet, Chef, SaltStack, and CF Engine are tools that are pretty common out there. Some of them can be used together. Other ones sort of compete with one another. And one tool that tends to be a bit of a Swiss Army knife and do everything that we find and can also integrate with other tools where it makes sense is Ansible. So I'm going to talk a little bit about how we use Ansible. So why would you automate? So we've got a few automation sweet spots. This is not an exhaustive list, but environment provisioning, configuration management, applying security baselines. So where Runecast can give you really excellent insight into how you're going security-wise, Ansible can help you automate the remediation. Operational tasks such as patching, and we've got a use case I'll talk a little bit about around infrastructure and application failover. So environment provisioning, a simple example, one of our team was working in a client where they had a 4 to 5 day deployment down to 2 to 3 hours, which includes deploying all the virtual infrastructure, building a Kubernetes cluster, and deploying the application. And that's all obviously driven through their CI/CD pipeline process. We use Ansible as a deployment tool to do that. Configuration management. So we may want to make sure we have a large fleet of systems and we have a relatively small team managing a large amount of systems. Where if we need to resolve an issue or make a configuration change across a massive fleet of systems, we can do that centrally in a controlled way very, very quickly. Applying a security baseline. So how do I know that all of my systems meet all of the SIS controls? How do I make sure they're turned on? And is it auditable? Operational tasks such as patching. Now that could be server patching, but you can also, if you've got a large amount of ESX hosts and you've got a lot of VMware patching to do, You could use Ansible to evacuate hosts, trigger the patching, and then put all your VMs back again. Orchestrated infrastructure and application failover, which is a bit of a mouthful, but we use Ansible effectively as an alternative to VMware SRM. I'll talk a little bit about that, where we're able to perform a complete site failover in our environment and for our clients in under 15 minutes. It's quite good in the sense that it's able to extend to hypervisor storage, operating systems, applications, networks, to be able to provide the basic failover capability and all the kind of bespoke specific tasks to that customer. We're able to automate as well. So a simple example, we talk about speed and efficiency, but one example is consistency and making sure that the way you envisage something is the way it happens. So an example in life is my wife bought a teddy bear for our son and a knitting kit where you knit a teddy bear like old mate Philip on the left-hand side here. And unfortunately, Philip on the left came out on a production line, but hand knitted Philip, not so much. So you'd ask yourself, who did it best? And I'd probably say that, had Philip on the right come off a production line, things may have ended slightly differently. So what is Ansible? Ansible really has two core components. The first core component is Ansible Tower. Ansible Tower is the GUI, the web interface. It provides a REST API to connect to upstream systems, and it effectively provides all of the enterprise features sitting on top of Ansible. Beneath that, there's Ansible Engine, which is the command line tool. Both products are considered Ansible automation platform by Red Hat, and it's all open source. However, you can consume the open source, or if you're in a large enterprise and you need support from Red Hat if something goes wrong, this is all supportable by Red Hat. So what can I do with Ansible? So the things that typically you would want to do to automate your entire IT footprint is to do automation, configuration management, application deployment, provisioning, continuous delivery, security, and compliance. These are some of the use cases I mentioned earlier, but you want to be able to do them across multiple areas in your IT footprint. So be that firewalls, load balancers, I won't read out the whole list, but it's not just a server configuration management tool. Obviously, orchestrating the public cloud, hypervisors, as well as networks, certainly falls in the sweet spot of what Ansible can do. So how Ansible works, and we're talking about a command line tool specifically here, you'll have an individual with a Ansible Engine, the command line tool, installed on a laptop or on a build server somewhere. They write a playbook. A playbook contains a list of tasks that describe the desired state that you want your system or environment to look like. Ansible modules are what provide the integration. So there could be a VMware VM module to build a VM, for instance, or a module to copy a file or manipulate something on a server. So those modules, there's thousands of them that are provided as part of Ansible, which is what allows you to achieve a desired state that's targeted against an inventory. So there is such a thing as a dynamic inventory, but we'll talk about a static one here for this example. Some credentials. So obviously you need to pass it some SSH keys or however you're connecting to the target environment. And then it obviously goes off and it applies everything to your target environment. So what do you get out of the box? Early days, particularly with a lot of these open source automation tools, what you got out of the box was not much. Fortunately, things have moved on. If you look at Google Trends, for instance, you can see how the adoption of these type of tools are now so popular and so widespread in most IT shops that there's a lot of contribution now into the upstream. So Ansible has a site called Ansible Galaxy, so galaxy.ansible.com. And you can see here, I've got a screenshot of what it looks like when you logged in. And you can see this is just for Ansible roles. So an Ansible role is like a repeatable, I suppose, rolled up set of automation tasks to do something. It could be to configure an application or something to that effect. And you can see there's 25,000 of them available for download, and they're obviously ranked and scored based on linting and how good a quality the Ansible role is. So there's a lot available to be able to get going very quickly, and you don't have to try and reinvent the wheel yourself. There's a lot in the upstream community to help get you going. The other thing is content collections. So content collections are also available through Galaxy, but if you have a Red Hat support subscription, there are certified collections and certified partners who provide content that you can download through cloud.redhat.com. So it's got a few example vendors there, so Cisco, IBM, Dell EMC. So there's, and VMware obviously provide a collection that you can download to be able to use to automate against those environments. So configuration management, I'll explain sort of a bit of a simpler example. So the first thing we'll define to manage our configuration, and obviously I've got one here which is a bit blanked out. These are some variables that we're passing to a playbook. So we're going to pass it, for instance, if we're going to set up a mail relay, what our mail relay will be. We want to set up NTP, so we want to know our time zone and our NTP servers. We may be using Nagios, so we want to know for monitoring what our Nagios server is. DNS, our DNS servers in our example.com domain. If we're setting up SSD and having our systems using LDAP authentication to log in, or Kerberos, we can specify that there, where we're sending logs to, so we may have a seam. So these are some basic things that you may want set up when a new server is deployed, and you want to make sure these things are set correctly all the time. So these variables can be fed to a configuration management playbook. And here's an example of one that we use. And here are some roles that it'll go and set out, such as go and set up my DNS, go and install all the packages that I expect as part of my SOE, make sure NTP audit D is set up SSD so that I can use my identity management system, set up postfix, harden SSHD, install any certificates that I might need, configure my sudo as time zone, set up the Nagios agent, set up forwarding to a SIEM, configure Red Hat Insights if you've got a RHEL subscription, apply a sys benchmark, and you may want to set up Telegraph, which is an open source metrics forwarding tool to be able to send it to InfluxDB or something like that. So effectively what can happen is you can have this run against your system or a fleet of systems rather on a regular interval. And you can also have it kick off every time a new system is built. So from a provisioning standpoint, and this is really where Talor comes in. If we think about when people want to build systems, looking at it from the bottom, you'd ask for a system, so log a call with someone, your IT department or a managed service provider. You'd wait for them to get off their backsides and build it for you, and eventually you'll get it. Typically, this is very manual, and it takes a lot of time. The new world is using things like self-service portals and having ready-made blueprints to go and deploy applications, infrastructure, etc. And that's where things like ServiceNow can come in, where you might have a ServiceNow workflow, and you can automatically trigger the API of Ansible Tower and go and run a provisioning process. And the last one is where it's completely embedded, where you might have a CI/CD pipeline where a developer makes a commit into Git, it triggers a pipeline, and your functioning infrastructure is spat out the other end. Obviously, everyone's looking to go at varying levels of this to get from the bottom to the top. And it obviously depends on a level of maturity and what your requirements are and who are the team running it. But it's effectively getting to one of those top two. Ansible is certainly a valuable tool to be able to help you get there. So what does that look like? So you might have a situation where you've got a service layer. So you might have ServiceNow where business users are kicking off requesting things. Or you might have a developer using something like Jenkins or Bitbucket pipelines or a variety of different tools, Azure DevOps, AWS Code Commit, where it'll trigger the Tower API as part of a pipeline process or a ServiceNow workflow. Tower will then go and provision and configure your environments, which could be on-prem private cloud with VMware, or it could be any of the major cloud hyperscalers. And then it can go off and talk to operating systems, Linux. And one thing that I haven't really mentioned is Ansible also has a significant amount of capability to be able to manage Windows, as well as just looking after Linux hosts and networks and all that sort of stuff. So when we look at when Ansible goes to provisioning environment, what actually happens? So this is an example playbook that you can do, and you'll see there's things in squiggly brackets, which are variables that are passed externally, which we might tell it, what's our data center variable, what's our template that we want to use, what's the name, what's the CPU, memory, data store, etc. And they're passed to the Ansible module, which I've highlighted here is the VMware guest module. So in YAML, we've passed it a file that describes the virtual machine that we'd like to provision. And what it also does is we've got the curl command here running a callback. So you can actually go and when the machine is provisioned, when it boots up, it can run this command and say, hey, Ansible Tower, I'm a new virtual machine, come and configure me. It'll go and add you to the inventory and run all the necessary playbooks to configure up a new virtual machine. So you can make sure when something's built and join as part of your Linux fleet, all of the security hardening and standard configuration goes across it. And you can also deploy the application all in one hit. So it all happens together. Ansible then will, looking down the bottom here, will wait for the system to come up to make sure SSH is available before it moves on to any further steps. So to provision a VM is very, very simple. And it's the same process, and you can have loops and all that sort of stuff if you want to create many VMs in a quite complex environment and then go and install applications afterwards. We've got a booth going, so I'm happy to answer any questions or give any demos to people. I'm more than happy to do that around some of the use cases and how to get things going, because this is obviously at a very, very high level. So environment provisioning, once again, going into a little bit more detail, you have an IT operations team and you've got a standard operating process. And the one I mentioned earlier down the bottom, IT would go and follow that process to get something built. But if you were to, say, put in the middle a Git system and source code repository, you can then start to look at, adding a branch, making some changes, creating a pull request, and adding your Ansible playbooks and all the configuration associated with them into version control. The next step that can happen there is you could be polling or push to a Jenkins pipeline where you're able to test your changes against an infrastructure, understand if it worked, send it out to Slack so people know what's going on, and notify that there's a pull request there that's got a build pass that's ready for approval if it wants to be merged. From there, you can go and have Tower kick off and say, right, now I'm ready to go. I'll pull down the latest set of playbooks from source control, notify people that through Slack or whatever mechanism you want to use that there's a deployment kicking off, and away it goes. So effectively, there's really a completely hands-off process here where you can go from IT operations, making a commit into a Git repository, to having everything automatically tested, an approval process, and your environment spat out the other side. So once we've got all the environment provisions, what about day two operations? So simple examples, patching. So on the left-hand side, this is how we do all of our patching internally or part of the steps that we use, where the first thing that happens is every time we build a server, we make sure there is a script, use the local bin stop.sh to stop whatever app is running on there. So the first thing it'll do is follow these, you can actually have a block of tasks that run together. So we'll go and see if our stop script exists. And if it does, we'll go and run it. We'll do a yum update to make sure all the latest patches are applied in our system. We'll do a reboot and we'll rinse and repeat. And typically we do, 5-10 servers at a time and have it roll through our fleet, and we're able to get our patching done very, very quickly with the most minimal of human intervention. Conversely, with Windows, you can do exactly the same thing. So we can go and provide a playbook that goes and installs, critical security updates on Windows. And the same thing, we'll go and register the result if it's been upgraded. And if we need to do a reboot, it'll go and reboot our Windows server at the end. So patching for both Linux and Windows, as simple examples, is very, very easy. There's a pretty low barrier to entry here. Like, you don't need to know how to learn you don't need to code in Python. You don't need to know a lot of that stuff. I mean, you can if you want to get quite advanced with the tools. But for IT operation team to get going, there's some very simple things you can do to get started. So another example that may be less common is disaster recovery. So we talked about provisioning and configuration management, but also any kind of orchestrated task that you want to do can be very easy. So internally, we had to have a look at how we were going to have an effective disaster recovery process. And the first thing we did was have a look at SRM. And I suppose we were being a little bit cheap at the time. And for us, if we think of the Goldilocks and the three little bears, SRM, it was too costly. Next, we looked at roll your own. So we could write scripts in PowerShell or Go or Python that are able to talk to the vSphere API and to our storage and to other things in our environment, where we'd be able to, write scripts and so on to be able to pull all of this together into a complete DR process. But it just seemed too hard. So, again, VMware SRM was too complex. Roll your own was too costly. Roll your own was too complex. Ansible was just right. It had a low barrier of entry. Our team know it. All of the modules and integration is already there, making it very easy to use. So we're able to get going straight away. We actually written an article about how we did this in a little bit more detail, and I've got the link there. If you went to our website, that's available. So the way it worked was we have a management environment, which I alluded to in earlier slides, where we run a lot of our tools. And we're a partner of Equinix and use Equinix as a data center and connectivity provider. So our management environment is running in a public cloud, and we use Equinix ECX, or the Equinix Cloud Exchange, to be able to connect to it. We've got two data centers. In our case, it's ME1 and ME4 in Melbourne. And we use the Equinix Metro Connect, which is a diverse path connectivity between the two sites. So it's pretty simple, our environment. We've got a set of storage and servers and networks and all the rest of it at each site, and a vCenter at each site. And we replicate our storage, and the DR process is pretty simple. We mount all our storage on the DR ESXi VMware environment, import all our virtual machines, and away we go. When you have a lot of virtual machines, which we do, doing that manually is simply not feasible. So we automated it with Ansible. So what I'm showing here is the Tower interface, and we've got a playbook that will go and fire up DR in ME1, which is our disaster recovery site, and shut it down afterwards if we're doing a test. You can see these little green dots are all of the times we've tried it, and fortunately they've all been successful, which is always a plus. So all we do is we click on it and we're asked a survey, is this a DR test, or has everything hit the fan and it's a real DR? So we're able to check that, and it'll go and kick it off, and 15 minutes later, everything's up and running at the other side. So to give an example of some of the modules and how we use them to actually make this work, one of the key parts of it is to be able to import clone data stores. So there's an Ansible module where this is actually an open source third-party module that we're able to use. There's an open source project called Ansible Forklift that you can find on GitHub, where someone has done a fantastic job, and we're able to pinch a couple of things that they'd used, and this import clone data store module certainly helped. We were basically able to go and give it a snapshot data store, and it'll bring it in, rename it, and we just have to go and gather. We have Ansible talking to our storage, so go and find out what's the UUID of the disk, and be able to pass that to the module. So we've got here, import clone data store. We tell it that's the module name. We tell it how to connect to vSphere. So these are variables passed from Ansible Tower. Our data center name, which is a variable as part of our DR process. We're going to import them on we can put this bracket 0, which means the first one. So we can import it on the first of our ESX hosts. We go and tell it what name we want it to be. We're going back a step. We're looping over information about our storage volumes and the volumes we want to import. So we can go and find out, well, what's the name of the data store? What's the UUID of the disk? And then it'll loop over all our volumes, and a few minutes later, they're all imported and into VMware. The next thing we need to do is register our virtual machines into the inventory. So there's a community VMware module, which will allow us to basically go and say our data center is Avet1, and we're going to import our virtual machines. We're going to give it an _DR name if we're doing a DR test. and we're able to actually find out the path of where the VMX file is stored. So actually, I'll go back a screen where one of the things that we do is we have on the top right-hand side here a fact repository web server. So Ansible can actually simply gather facts about your environment and post it somewhere to a web server. So what we are able to do as part of the DR process is continually capture what our environment looks like and describe our environment, store it in the form of facts on our web server, and go and query it later. So coming back to this step, when we want to know, I'm going to import a VM, what data store is it on, and what's its VMX path, we actually query that from our web server, which is very useful. The next thing we may want to do is change the UUID of the VM, and this is actually a custom module from the Ansible Forklift project on GitHub. And then we use the VMware guest power state module to go and fire up our VM if we've got an option here when we want to start them. So we can say, well, bring everything in, make sure it all comes up. It can be imported rather, but don't go and start everything up automatically. Or you can say, yep, go and start it, and put some logic in there and says, if it's, partner production one is up and running and have some tests, don't do it. Otherwise, bring it up. All that logic is really simple. And this is a bit of a cut down part of our process. So I'll talk just briefly about some of the benefits that we've observed, both for us and in our customers, of using these tools, both Runecast and Ansible. So looking at Runecast specifically, Runecast gave us a massive improvement in what our managed service offering is in VMware. So the capabilities that Runecast bring to the table, much of them we didn't have before. So when we're offering a managed service to our customers, we've got a much more compelling offering where Runecast is able to report on, is the environment up to date? Are there any best practices not being met? Are there any issues? So we can obviously work on making sure everything is all green and there's no issues in the environment. And the customer also has access to the Runecast Analyzer. And if they wanted to go and have a look, they can see that we're doing our job. The second part is ISO 27001 is a key requirement for us. And some of the capabilities just coming to Runecast to help us with our ISMS program is certainly very helpful. As I mentioned earlier, we try and align to SIS as a benchmark, so we can validate the SIS controls. We can validate VMware best practices. Are we doing the right things in the right way, and how do we know? We're starting to look at it in our AWS accounts, where Runecast can provide some guidance on best practices in AWS. And the feature of being able to add it into OpenShift and Kubernetes as a Red Hat partner, we've got a big focus on, obviously, Ansible, as I mentioned earlier, and also OpenShift. And we can point Runecast to that environment and can go and check some best practices and report back, which was pretty cool, and that's quite a new feature. So on the Ansible side, it enables what we'll call a smallish team to manage a very large and complex fleet of systems very easily. If we stopped using Ansible, we'd probably have to double the size of our team, at least, to be able to handle the work. From a cultural perspective, we don't build anything by hand anymore. We standardize and automatically deploy everything, which completely changes the engagement with our customers, because it goes from, we want you to do this, we go off and do it and tell them that it's done, where it becomes much more a collaborative approach of what more can we do? The ability to do things quickly, obviously, we can deploy a new environment in less than 5 minutes. As I mentioned earlier, that DR test takes less than 15 minutes to knock over for us, which it was a huge win. And our patching is fully automated. The more systems we take on, we can have an intelligent patching process. If there is a security issue that's identified, we're able to get it patched and get our systems looked after and our customers up to date very, very quickly. So that was it as far as the slides go. I'm looking at the chat at the moment. Just going to check if anyone's left or I've put people to sleep. If there are any questions, please post them in the chat, and I'll be happy to try and answer them as best I can. So I do have a question from Andre. What's next for Advent One? So what's next for us? I think growing our managed services offering in a standardized way is certainly one of the key focus areas for us. So generally, what we're finding is people, want to, if we look at automating something, for instance, people aren't really interested in someone coming up and setting up a tool and leaving them to it. If we look in the case of disaster recovery, I want to pay you to make sure my disaster recovery is automated and it always works. Or if we look at helping a customer migrate to a container platform, I want you to take care of getting everything up and running and get it ready for us, and make sure that all we have to worry about is dealing with the services that we want to deliver. So I think trying to expand the suite of services that we have and try and make things easy to consume and really targeted towards specific problems and things that will help people and their IT team be more effective is certainly one of the areas that we're looking at. So from a technical perspective, obviously cloud, containers, automation, DevOps, they're the key areas that we're looking to obviously grow as the industry demands it. But certainly we're also very keen to help people with some more bespoke and challenging use cases where we seem to be drawn towards being able to help people there. This is the output in Ansible Tower, so we can go and see that, and some of the things that we've worked through. So we'll go and build a list of storage volumes that we want to process on our storage. We go and map. We create flash copies or snapshots of our storage LUNs. We then go and map them to our ESX hosts. And then we follow through all these steps where we go and work out the vdisk UID and so on. Go and map the host, map the storage to all of our hosts. We then go and re-signature and remount all of our data stores. We'll go up through this a little bit. So we can see it's going through that process, but if I scroll right to the end, thank you. So you are. Sorry, Andreas, to try and answer your question as best I can. So we do use Tower. Well, we also integrate it with HashiCorp Vault as a secrets repository. Because we might have a secret that we want scripts and that sort of thing to be able to access or to store them outside of Tower. So Tower with RBAC, we certainly do Tower as an API endpoint. We can run on-demand playbooks with a survey. So that the idea for us is that we've got a number of use cases, and Tower, we find that if we can use that centrally, tends to tick as many of them off as we can, which makes it a little bit easier for us, and it works well for our team. They're coming back through this. If I go right all the way to the end, there's 1,700 lines of stuff, and it's gone and imported VMs. But all of the things that it did, this took 16 minutes and 26 seconds to go and import everything. But doing that manually would have certainly taken a lot longer than 16 minutes, which is very useful for us. All right. In that case, please feel free to come and see us at the booth, and I might end the session now. And thanks very much for coming and listening to me.